My name's Chris. Before we get started, I just want to get a feel for how much people know about what I'm going to talk about already. So raise your hands, if you will, if you've ever written any LISP. And leave them up. Raise your hands if you've ever written any scheme or closure. You can leave your hands up. Closure. Raise your hands if you've ever run anything on a Python virtual machine. All of your hands can stay up. Okay, so by the end of my talk, everybody with their hand up is probably going to feel annoyed and horrified. So what is Hi? Hi is pi times Lisp. So basically, it's Python, but with a Lisp syntax on it. So what is Lisp? Lisp is this guy. If you write any Lisp, you too can wear a weird hat. So here's this guy's Gerald J. Sussman, and his talk was Structure and Interpretation of Computer Programs. It's a famous talk, and the reason it's famous is because it elucidates a lot of fundamental computer science concepts. And it used to be done in Lisp, and I think it is now actually done in Python. So this guy, Alan Kay, you guys have heard of him? He said Lisp is the greatest single programming language ever designed.
Well, what year did you say?
Good question.
Is he wearing a hat?
He probably was wearing a silly hat. I'm sure it was a fedora or something. It's not actually one language, it's a family of languages. So sorry, Alan.
It was one once.
It's true, it was one once. Within a couple of weeks of learning Lisp, I found programming in any other language unbearably constraining. Unbearably constraining. So he opened up his text editor with some C, and he was like, "Oh, I feel so constrained." Yeah, that deserves this one. It's not that bad, Paul. Lisp is worth learning for the experience you will have when you finally get it. That experience will make you a better programmer. That's a photo of Eric S. Raymond. Yeah, he wrote fetch mail, right? It's an abomination. So that's all hype. What is Lisp actually? Wikipedia says it's a family of computer programming languages with a long history and a distinctive, fully parenthesized prefix notation. So you guys will know about the parentheses from Lisp, right? It's all brackets. That's what everyone complains about. So many brackets. Originally specified in 1958, so it's the second oldest high-level programming language after Fortran, and we all know how well Fortran worked out. It's still in use, and so is Lisp. This guy wrote the original paper, John McCarthy, and his paper was called Recursive Functions of Symbolic Expressions and Their Computation by a Machine. I mean, I'm not much of an academic, but this is actually a really good paper. It outlines some really fundamental computer science ideas, and I think I read it years before I ever wrote any Lisp code, and I thought it was good even then. And I was still like, why the hell would I do this bracket thing? So what is Lisp? According to Wikipedia again, the name Lisp derives from list processor. Lisp source code is made of lists. So just internalize that for a second. Lisp source code is made of lists. Source code as data. Yeah, this was the Wikipedia phase when they were turning everything into those tongue twisters. Source code is made of lists. So let's take a bit of Python 3 code. We've got a function, print, and we've got a string, which is the first argument to the function, hello world. If we were to turn that into a list, where the source code was made of lists, it might look something like this. So we've got a Python list. The first element is print. The second element is hello world, a string. So Python actually does something like this internally when it parses the Python source code into an internal representation that it uses to run on the machine. It's called the abstract syntax tree, and it looks something like a list of lists. I mean, it's much more complicated, but that's the basic idea. Now, this idea is called homoiconicity, which is a mouthful to say that the program structure, so the way it is in the memory, is the same as how it looks when you write the code. So a language like Python isn't much like that because the structure internally looks like the AST. So it looks like lists of data structures of functions calling themselves. Whereas Lisp is like that because the program structure is the same as the representation in memory, the syntax that you write it in. So Hi is Python with a Lisp syntax and Lisp features. So what does the Lisp syntax look like? Let's have a look at a bit of Python here. We have a range function, and it's being passed one argument. Pretty simple. The same thing in Hi looks like this. And that's basically the fundamental difference between Lisp and other languages. So you've got pi, hi, pi, hi. You can see what's happening there, the bracket. So in Lisp, the first element is the function, the rest of the elements to the list are the arguments. So what happens if we've got a function like this in Python? Range 10, 20. We've got two arguments now, one function call. That's what it looks like in Hi. So it's a list with the first argument being the function and the second, and the arguments to that function being the other elements of the list. Whoops. Shit. Sorry. So yeah. This is pi, hi, pi, hi. So what else is different here? What happened to that colon? That comma. Think about it for a second. You don't need the comma. The comma is totally superfluous. Now, Python's a language which is really good at getting rid of superfluous junk, like those curly braces that all those other silly languages have. But it's still got the comma, which it doesn't actually need. So here's a print statement from Python, the same one we had before. So in the AST it looks like this. That's what we looked at before, a Python list with the first element being the function, second element being the first argument. This is what it looks like in Hi. We've got pi, hi. Very simple. We're just popping the position of that bracket to before the function. So let's look at something a little bit more complicated. Here we've got a function definition. We don't have the body of the function. We're just looking at the definition part. In Highlang, it looks like this. So the defin is the function. The hello is a symbol, which is the first argument to the defin function. And then we've got this weird square brackets thing. What the heck is that? So let's look at a Python data structure. We've got an array here with 1, 2, 3, 4, 5 in it. In Hi, it looks like this. So exactly the same thing, we just get rid of the commas. So you can use native Python data structures in Hi, and all you do is don't write the commas. You can if you want, but you may as well not, because what's the point in them? All right, here's a Python dictionary. Here's the same thing in Hi. Once again, we get rid of all the superfluous syntax that we don't need. So these colons. What's the point of colons? A dictionary is always key value. There's no point in having the colons. There's no point in having the commas.
What about a set?
A set, I'm not sure how that is in Hi. I know how it is in Clojure. In Clojure you do a hash before the braces.
Okay.
In Hi you would, if there isn't these things are called reader macros. If there isn't a reader macro for set, you'd probably just use the Python set function.
Sure.
So you'd do something like bracket set
And then you're
array. Yeah. So here we have 2 plus 1, a Python expression. Same thing in Hi. Plus is the function. The arguments are 2 and 1. Actually, that's the same as that, but it's just more consistent. And that's the deep thing about Lisp, a high level of consistency. So one of the deep things. Here's 5 numbers being multiplied together. 5 times 4 times 3 times 2 times 1 in Python. Same thing in Hi. Multiply is the function. The arguments are 5, 4, 3, 2, and 1. So you can see the consistency coming through. In Python, we've got math.py. This is a module, and we're looking up an element of that module. What's that called? Not an element. Not a method. A property. That's the one. Looking up a property on math. So in Hi, we can do this. Dot is the function, and what that function does is look up the property on the first symbol, which is the second symbol. And actually, you can do the same thing. There's a shortcut in Hi that lets you do the same thing as Python, right? I'll get past this bit quickly. Sorry, I know it's a bit confusing. From elephant import peanut trunk. So this is a piece of Python. I'm running through a bunch of code examples so you can get a feel for how the language is. So from elephant import peanut trunk. Hi does this a little bit more concisely, which is import. Our module is elephant. So our first argument to import is an array. The first element of the array is the module that we want to import. It's actually a symbol for the module. The second argument is an array with the symbols for the things that we want to import from that module. But it's basically the same as that. From elephant, import peanut trunk. The only difference is that the syntax is consistent with the rest of the language. So here we're assigning two variables, x to 12, 15 to y, 12 to x, 15 to y, and then we're multiplying them and printing the result. The same thing in high, you might do this. Def, which is a function which assigns a value to a symbol. And our symbol is x and our value is 12, right? So again, it's consistent. But this is horrendous, don't do this. Def basically declares a global variable. It's not a great idea. A better thing to do is enclose it in a let statement. Now this is functionally equivalent to this. We're going let x be 12, let y be 15, and then multiply those two numbers together. So let x be 12, let y be 15. Now notice, here we've got an open bracket. This is the closed bracket for the let. So this stuff here is enclosed within this statement, right? So this binding of x to 12 and y to 15 only lasts for the duration of until the end of this bracket. So then we're multiplying x and y and then we're printing it. It's exactly the same as this. The only difference is this leaks all over the rest of your program, whereas this doesn't. You've enclosed the variables. I mean, you can do the same thing with a Python function, but in a Lisp, it's built in. So here's back to our original function declaration, except this time we've got a function body. Here's Python, here's high. As you can see, we can see that those square brackets again, but now we know what they are. They're just a Python array. So defen will create a function for us. It'll use this symbol as the name of the function, and then any arguments we want, we put them in an array, symbols in an array. Then the body of the function is print hello world. Simple. What happens if we want to put an argument in? Here's a piece of Python. Hello person. So what it's doing is concatenating the string hello with the variable we pass in person and printing it out. The same thing in Highlang looks like this. So we're creating a new function. The function takes one argument, this symbol person, and then we're going to use the plus function and add the string to person. It's exactly the same as that. The only difference is the syntax is consistent with the rest of the language. It's all Lisp. Can anyone work out what this does?
Prints hello Bob.
Yep, prints hello Bob. So you can't do this in Python. What we're doing here is from here, this bracket, to this bracket, we're declaring an anonymous function. The anonymous function takes one argument, person. It adds hello to person the same as we did before, except it's an anonymous function. Fn means it's an anonymous function. We add hello to person and we print it out. Then, once we've finished defining the function, the first thing we're doing is calling that, because it's the first element of this list, which ends here. We're calling this as well as declaring it. So we're declaring it and calling it with one argument, Bob. So it prints out hello Bob. What?
I saw the title, didn't exist. Can't you do that with lambda? You can't call it lambda?
Good question. Can you do it with lambda?
Yes,
Not
but
a
very, very difficultly.
Yeah.
Print.
You can't do print.
You can, it's just not
Yeah.
prints.
Yeah, you're right. You can do it with lambda, just very, very difficultly. I will show you something you can't do with lambda. All right. So, anyone who wants to try high, super simple. That's it. Pip install high, and you get a whole new language on top of Python. So, of course, you wouldn't want to do that. You'll create a virtual env first. You'll set up a new project, but you can copy paste this code from my slides. Make dir my high, cd my high, create a virtual env, get into it, and then do pip install high. But basically, pip install high is it. Once you've got it installed, you can run it, and you can see it tells you which version of Python it's running on. So 2.7.6. So it is still Python under the hood. High compiles down to Python bytecode. and it actually uses the Python AST. Before I talked about the AST, the abstract syntax tree, Hi compiles to that. And then you get a REPL like you do with Python, and you can type stuff there. So here what we're doing is running Python's X range with an argument of 10, turning it into a list, and the result we get is a Python list. That is 100% Python, the thing that comes out. So let's talk about some fun things you can do with Hi. Full Python interop. So you can go, you've got a module math, you want to import the sign function, you say import math sign, and then you can use it. That's a normal Python function. You can do it with almost any Python function, sign 0.5. Now let's say we, in Hi, declare a new function called half sign. What this function does is, has a single argument x, it divides x by 2, and then takes the sign, runs the sign function on it. Now I should point out here, Lisp, the way it works is, the last thing inside the current closure is what is returned. You don't have to have a return statement because this, by default, will get returned. So, yeah, anyway. So we've declared a new function, half sign, takes half of x, sign, returns it. What can we do with that? We save it into myHiModule.hi. Then we go back to Python, because our code base is written in Python. We just happen to write a few functions in Hi because maybe we feel like experimenting. So from Python, the first thing you have to do to use Hilang modules is import Hi. That sets up the machinery for correctly importing the source code. Then you can say, just like in Python, from my Hi module, import half sign. So that was the function we declared in Hi. And then you can use it. Half sign 2.23, whatever. So there's full interop both ways. You can use Hi from Python and Python from Hi. Another great thing about Hi is high language density. Now, language density basically means how much expressive power you get from every character you put into the text file. Python is already a very dense language. You can fit a lot of expressivity into Python, and it's also easy to read. So it's got that going for it. Sometimes Python code will actually be denser than the Lisp equivalent, which is quite rare. Normally when you start coding in Lisp, it ends up much denser than the original language. Another great thing, what we were talking about before, true lambda. So in Python, you've got a lambda like this. So here we're passing in an array to the function sorted. You guys know the function sorted? So it's sorting arrays. We're passing an array 2, 1, negative 3 into sorted. We're saying our key function will be lambda x, and lambda x will be squaring x. So multiply x by itself. So what you'll end up with basically is 1, 2, 3. 1, 2, negative 3.
Oh, yeah.
Same thing in Hilang. Looks like this. So no commas in the array because commas are terrible. We're calling the sorted function on the array. Our key function, we're going to declare now. We don't use a lambda, we use an anonymous function declaration. So this from here to here is our anonymous function that we want to use. Argument is x, same thing. Multiply function by x 2 times. So that's exactly functionally equivalent to that.
So keyword arguments, you use the colon key.
Yeah, that colon thing.
I mean, it's not like it's a keyword in.
It's the same as a keyword enclosure. It's not the same because it's worse, but it's a similar concept. I'm not going to go into it because it's like too complicated. But yeah, basically you can use keywords like enclosure. Here's what you can't do in Python. 2 statements. So what this will do is, as the array is being sorted, it will print out every number that it's running through this function. So that's a lambda with 2 statements. Basically, you can't do that in Python. What you can do in Python is declare your function separately and then pass that in as the argument to key. I mean, this comes in super useful for when you're writing functional code, basically, because you can declare functions inline, or you can pass functions to other functions, etc. Which you can do with Python. It's just more difficult.
Is there any limit to the number of sub-functions you can run?
I've never run up against one. I'm sure there is. Maybe the memory of your computer.
640K, right?
640K. What are you, Bill Gates?
That'd be real good for MicroPython.
I haven't actually tested whether High runs on MicroPython yet, but I sincerely doubt it. It'd be super cool.
Python bytecode run
I don't think so. Anyway, so threading macro. Lisp, the functional nature of Lisp means it can get quite dense, quite hard to read. So you have, here we move outwards, right? We take the sign of 0.2, then we add 3 to it, then we take a square root, right? So when you come across code like that, sometimes it can be a bit hard to parse. You have to like sit there reading it for quite a while. But we have this, which is the threading macro. And what that basically does is rewrites this code, which I'll talk about in a second, so that 0.2 is passed through sign, and then the result of that is passed through +3, and then the result of that is passed through math.square root. So it's functionally identical to that code, but it just looks nicer, and it's easy to read, yeah. So notice I said threading macro. So this thing here, this little widget here, it's not actually a function, it's a macro. So remember, the code in Lisp is data. You have lists of functions and arguments, right? So the code is data. Functions manipulate data. That's what functions do, right? So a macro is a function that manipulates code at compile time. In other words, this is running. This doesn't run when you run your program. It runs just before, and what it does is this function, instead of just applying these arguments into it, it runs a compile time, and it rewrites this code to look like this, right? Does that sound just batshit crazy or what?
But when you say rewrite, it's not actually writing it to an intermediate file or anything, but it just rewrites it internally. Yeah,
under the hood, in the AST basically, it rewrites the code to look like this. And that's what a macro is. It's kind of like a decorator on steroids. So a Python decorator, you can wrap a function in another function sort of thing, and spit out a new function. So what this does is it doesn't just wrap the original function. What it does is it actually passes the abstract syntax tree of what that function does through another function. So that means you can do insane things like, imagine you have some function which has a bunch of add functions in it. So you're adding a bunch of numbers together, adding a bunch of variables, right? So you've got a function, it's got all these add symbols in it. With a macro, one of the types of things you can do is run that through your macro and replace all those plus functions with multiply functions. So you could completely transform what the code actually does. It's don't ever use macros. They're like they're super powerful and they'll totally mess you up. But when you have to use them, you're just like, how did I ever write that? And they're what makes Lisp such a flexible system and such a powerful thing. But you don't often have to use them. But when you do, you basically transform your actual language into a new language, which is why Lisp is great for writing domain-specific languages, so new little languages, sub-languages.
For some reason, this is conjuring He-Man and that I've got the power.
That's a good image.
So a macro.
I've always thought I looked like He-Man. So
a macro is more for clarity than anything else, then.
no, not really. I mean that clarity thing is one use, but so a thing I've done before is I wrote a macro that took a piece of code. It was for doing unit tests. So it took a piece of code and it spat out the actual, like what the code was before running it. So that you could see this code ran and then this is what happened. So you can do it in Python, but once again, that'll be super difficult because you'd have to go into the AST and you'd have to turn the code back into code, Python code, and then display it. So yeah.
Not as difficult as it sounds.
Yeah. Maybe you went to Mensa, right?
No, you just don't use the AST, you use the trace back in the file line.
Oh, right, you look up the line. Yep, you could do that. You could do that.
AST is pretty cool, it was just running.
Alrighty. Alright, so loop recur is another thing I'll just quickly visit. Basically, Hi doesn't have great for loop. Its for loop is not functional, so it doesn't return the values that come out of it, which is super annoying. So I always end up using this thing, loop recur, which is a very Lisp thing. First thing you have to do is, for some reason, require hi.contrib.loop, and this imports the loop macro. So we talked about macros before. A lot of the stuff I've shown you already are actually macros. The let is a macro. The defen, I'm pretty sure, is a macro, or maybe a built-in. But
So how's require different to import?
require is just for macros. So it's not a Python thing, it's a hi only thing.
Okay.
Because the macros aren't in Python.
Yeah. Gotcha.
So you require the loop. Let's go through this loop line by line quickly. Sorry, I know this is very code heavy. But you are developers, right? You love code. So this loop, here we're passing it a array, a Python array. We're binding the symbol x to 0, initial values. The symbol a to an empty list, a normal Python empty list, right? First line of the loop, actually the only line of the loop. The first line of the loop, we're comparing x, which is 0. Is it less than 12? An if statement basically checks the condition, and then it runs the first thing if the condition is true, and it runs the second thing if the condition is false. Anyway, x is less than 12 because it's 0, so then it's going to run recur. What recur does is it's as if we've written an anonymous function here, and this is calling itself, right? But if you had an actual anonymous function, you can't call it because it's got no name. So loop recur provides a facility to do that. So recur then runs loop again, so it runs this as if it was a function, and the arguments it passes in are these new ones here. So increment x will become 1. Add to a list with the value of x. So a will become 0, a little Python list with 0 in it. So we'll have x is 1, a is a list with 0 in it. Second time through the loop, x is still less than 12 because it's now 1. Recur again, increment it again. X is now 2. This here becomes a, which is a Python list with 0 in it, plus a Python list with 1. So it becomes a list with 0, 1, and so on. And you keep doing that until we hit x is less than 12, by which time x is greater than 12, x is equal to 12, by which time this list here has filled up with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and the condition is false, so we run this line instead. Now remember I said that in Lisp there is an implicit return. The last thing in the scope is what gets returned. So this just gets returned out the back of the loop. And we end up with a Python list which is, maybe I should run this. No, I can't be bothered. You end up with a Python list which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This takes advantage of something called tail call optimization. Lisp people are always talking about this. Basically, the long and short of it is, I don't know if has anyone ever smashed the stack in Python? Yeah, of course you have. So you're calling the same function so many times in a recursive way that you run out of stack space. So tail call optimization is a way to avoid that. This won't run out of stack space. Well, it basically unpacks. It unpacks so that instead of calling a new function every time, it lays the loop out long. Destructuring. Destructuring is like unpacking values from larger values, so taking an array and just getting bits out of it. So in Python, you know when you go x, y equals brackets 1, 2, and those two values go into x and y? Same kind of thing. So here we've declared a function called multar, and we've got 2 arguments. The first argument, we're saying we expect an array with 2 values, x and y. The second argument, we expect one value, z. And then let's multiply them all together. So here's an example of calling it. Multar, pass in an array, 1 and 2 will go into x and y, 3 will go into z. Basically, it's an efficiency. Makes more concise code. Instead of having to put a single value in here and then unpack the array, it does it at the call time. Functional programming. If anyone saw Crispin's talk on functional programming a few months ago, Lisp is a functional programming system, so Hi enables functional programming much more easily in Python. If you like functional programming, if you like the lack of bugs that functional programming leads to, then you should definitely check out Hi, because it's good for that. As you can see from that loop example, this thing here, all this big thing here, and this just gets returned out the back of it. It's not a function, but that's just how it works. Object orientation, it's a horrendous abomination, don't do it. But you can if you want in High. It's got the same built-in Python class and all that kind of bullshit. The best thing of all about programming Lisp, I've left for last, and that is the text editor integration. So the text editor integration, I know you like when you're writing Java, you've got those things that spit out boilerplate code for you and stuff like that. The text editor integration when you're programming Lisp makes you feel like a total ninja. Actually, it makes you feel like a ninja times you times infinity. Basically, it means that you can manipulate code with single keystrokes. So you can, if you've got, like when you're refactoring or something like that, you can just grab whole bits of code without ever touching the mouse, strip them out, pop them somewhere else, turn it into a function, bang, seconds. It's really great for refactoring, and the most important thing is it makes you feel like a ninja. So we've got these different plugins, Parrot, Slime, Emacs, I don't know the names of the other ones, but Emacs is not a plugin, it's a text editor. Who uses Emacs?
And so, alright, Emacs, like when you're building plugins for it and stuff, is
Who invited the ninja? What's that?
When you're writing plugins for Emacs, it's all kind of Lispy as well.
Yeah, Emacs's base system is written in Lisp already, so of course it's really great for programming Lisp. But I code in Vim. You can install Parrot, and you can be almost as much of a ninja as an Emacs person, or you think you are, but they're up on some other fucking level. Live coding is a really great thing that a lot of Lisps do. Clojure is awesome at this. Basically, well, what it means is you can have your program running and you're writing bits of code and you're like, oh, I really want to just insert that bit of code into the running program. I don't want to have to restart and get my state back again. And that's what you do. You just push a bit of running code into the running code, and it'll update the function. So an example is, let's say you're writing a game and you've got an animation loop, and every loop you're updating the state of some ship, right? Some AI. Let's say you're programming an AI. What you can do with live coding is push a new function saying this is how the AI should behave in real time, and it'll update the AI as you're looking at the game. You don't have to restart the game. You don't have to get out of the state. So it's super useful for closing that tight iterative cycle. High is not that great at this, actually. There are people working on it, but it doesn't have the same level of real-time live coding as some other Lisp-based environments do. I'm going to show a very quick video. How much time do we have? Am I being super fast? 33 minutes, all right. Is anyone bored? What's going on? Oh. Video 2. Now, you probably won't be able to read the text, so I'm just going to narrate. It's only 1 minute long. Oh shit, it's on the wrong desktop. Can you read that code? No. So what it's doing is, so this is Highlang. Basically, I rigged this Highlang live coding system into Blender. This is Blender, which you might know has Python in the back end. So what I'm doing here is declaring a for loop for range in 100, and then add a cube. So it's going to add 100 cubes. It's applying the cube function with a location of, and then it's multiplying the z by 3. So then we end up with cubes. We end up with cubes that are separated by 3, right? 100 of them. So then I went down there and went, make it only 10, because that was a crazy tall stack. And then 5. And then what I did was, from random, so I'm importing the random number generator. And I'm using a random number generator for the z value, x, y, for the y value. So you can see those things are shifting around in the y. And then I did the same thing. I changed the range so that it's making 20 blocks instead of 10. And then I did the same thing with the random numbers to the Z value. So we end up with this kind of like this wall of randomly placed blocks. And then the same thing to the X value. So that should give us a cube of cubes. Yeah, there's a cube of cubes. And then I made 100 of them just to go crazy. So there's a cube of cubes in Python in less than a minute. In Highline, in less than a minute in Blender.
Is there a reason why this can be done just with Python?
Oh, it can be done with Python. It just, coding it would be more painful, I think. Maybe not.
Makes Minecraft rules.
What's that? Yeah, that's
Makes
right.
Minecraft rules.
Programmable Minecraft, very cool. So, if you think this stuff is interesting, if you think, wow, that Lisp thing, it seems a bit mad, but I would like to check it out more, here's some rabbit holes you can go down. Check out Clojure and ClojureScript. Super powerful. The next big thing or something. Maybe not. Immutable data structures. So, functional programming is cool. Immutability is way cooler because it means you can't change any of your variables, so you never have bugs. Why do you need to change variables? What's wrong with you people? No, it basically means that you isolate the places in your code, and you have to be really careful about defining where in your code you make changes to variables. And that means less bugs. Same as functional programming, less bugs. And who wants to spend their whole life debugging? Core.async is a thing from Clojure as well, and it is great. It's basically they took Go's concurrent sequential processes system and like copied it kind of. And it's a really good way of doing like threading kind of stuff, like multi-parallel processing. Very concise language, and it puts things in a way that, what's the right word? Blocking. Everything seems like it's blocking. So your code works sequentially. Unlike JavaScript where everything's callback hell, and you get lost in like which callback is being called where, and you end up with these nested things. It's much cleaner and less bug prone. Wisp and Mal are two interesting projects that I love. Wisp is a super minimal Clojure-like for JavaScript. So basically they've just taken the Clojure-like syntax and written a Lisp that gets compiled to. No one will go check that out. It's terribly esoteric and weird. And Mal is another super cool project, which is one of the fun things to do with Lisp is implement your own Lisp. You can implement your own Lisp in like 1,000 lines of C. Tiny. And what Mal aims to do is implement a Clojure-like Lisp in every other language. So they've got, I don't know how many now, like 30 different languages. Like there's a PHP version of Clojure-like Lisp. Well, just for kicks, you know, why not? No, it's an educational thing. It's like, the same as reading the Lisp paper. The original Lisp paper gives you a deeper insight into computer science as a whole. And writing your own Lisp is the same thing. It gives you like just an appreciation of how data structures work. There's that quote, which I will misquote, but it's like every sufficiently complicated C program has embedded in it a buggy, half-specified version of Lisp, which is true. Like if you've ever worked on any large program, it eventually gets meta and tries to do things, but just horrendously and in C and just wrong, where they should just embed a Lisp in it.
I've heard the same quote with Scheme.
Scheme's a dialect of Lisp, pretty much, yeah. And that's the other thing I should have added to Rabbit Hole is there's a bunch of different schemes which are ancient, and there's like Common Lisp, which is another Lisp, and there's Gambit Scheme and Chicken Scheme, which compile down to actual machine code. So if you get excited about this stuff and it seems pretty cool and you learn a little bit of Lisp, suddenly this whole world is opened up to you. Good times. So Hi is a fun and fast way to learn you some Lisp, and you just have to do pip install Hi. That's my talk. Thank you very much. Should I take questions, or you want to do your one?
Yeah.
There's enough time. Yeah, if you don't stick around, we'll take like 10 minutes questions or 5 minutes questions.
Yeah, why did you get into it, into Hi? Was it, the Blender stuff, or what was your motivation to start?
A friend of mine who's sitting over there was raving at me for about 3 years about this Clojure thing, and I was like, Jesus, not another language. And eventually we did a game jam, and I'd learned Clojure, And for 2 weeks solid, I dreamed in parentheses. I'm not even kidding. That's what happened. And then, like, I was exploring it a bit more, and there was this high thing as well.
Okay. So is there anything unique to it that you can't do in Python?
Yeah, the lambda.
Okay.
And also be a ninja. Can you be a ninja in Python? Like, be a ninja?
Important.
A code ninja?
Okay.
Yeah. I mean, no, it's like, it's that whole text editor integration thing is a bit hard to convey. It's something you really have to try and then discover how awesome it is.
So is it more just the preference of the syntax?
The ease of doing functional programming, I mean, the thing is, I always found when I was writing Python code, I was always trying to write it functionally. And Python has a lot of great stuff in it that helps you with that, Lisp comprehensions, stuff like that. But doing proper functional in Lisp is like, it was such a relief. It was just like, oh, this is how you do this right. You know what I mean?
Just easy to understand.
Yeah, easy to code and just like more consistent. Yep. Oh, Crispin, do you have a question?
Yeah, how do you, like, with your .hy file, how do you boot, like, if that's your only file, let's say you do mainline into hy,
Yeah.
how do I launch, do I go Python file name.hy?
Oh no, I covered that right at the start. I'll just zip back to it. Basically like this. You just run hi.
So you go hi space.
Yeah, it gives you not a binary, but yeah, it gives you a Python script called hi. Yeah. And the one place where that gets slightly tricky is like if you're packaging it up, like Exe or something like that.
Put a shebang on it and go.
Yeah, you can do it with shebang. Yep. And one what happened? One area where it's pretty good is writing like little scripts, because the one advantage it has over Clojure is that it launches very quickly. So if you want to write a shell script in Lisp, hi is a good way to do it. You get the full power of Python, you get to write Lisp, and it boots instantly. Well, not instantly, but yeah, pretty quick.
Not the JVM.
Not the JVM, which, to be honest, nowadays isn't that slow, but yeah.
Have you played with Lisp flavored Erlang or Elixir at all?
No, that guy has.
I was just going to see if you had any thoughts on whether this felt more functional than them.
I don't know, what do you reckon, Crispin?
I haven't used Python.
Oh, okay.
Oh yeah. Regarding this destructuring, is it lists only, or can you do dictionary?
Do you know, I can't remember. Yeah, I don't remember. I'm pretty sure... No, I don't know.
Okay. So do you use hi in your given one?
Yeah, don't tell anyone. I have deployed some hi in production. But that's basically so no other programmer can take my job. Like,
And what's the, so when you're thinking when you're thinking of Python as like an OO language, and you normally have like, you'd separate it, like maybe you'd have like a Python file per class or something like that.
yeah.
Like, how do you kind of decompose a large high program into these modules? Like, would it be kind of like...
It's pretty much like C. I mean, if you're writing functionally and if you've graduated beyond object orientation, don't get pissed off. If you've graduated beyond object orientation and you're writing like functional code, it's kind of like C. You have modules, like namespaces effectively, with functions within them.
Yeah, so it'd be like you'd have a set of related functions in one
Yeah, exactly. You logically group them under a namespace.
Yeah.
Namespaces, these are great. We should use more of these.
Exactly. Yeah, does hi have its own version of import this?
Import this. What is oh, that's like when
The
it
Zen-
shows
the
the
Zen and Python,
Zen.
yeah.
I'm not sure actually. I should try that.
You can probably get Python one.
Import this. It'll probably show the Python one. Yeah.
Zen and Python. Yep.
Take that, hi.
You totally have
We
time.
got some Python in your
That's more Zen than the original.
Yeah.
What's the OO interrupt like? Like, I understand you can do it, but is it, like, if you're working with a big OO library, is it like...
Oh, if you're using other stuff.
Python?
I mean, if you're calling existing OO stuff, it's exactly like Python. So you...
Like instantiating objects and, like, obviously mutating them and...
Yeah, it's the same. Like you've got set exclamation mark, or no, set v, which sets a variable in the Python way, so it like doesn't equals. And so you could mutate things like that if you wanted to. And I mean, like for that Blender thing, I had to import Blender's modules and I had to instantiate objects and then use them. I mean, you can use existing object-oriented stuff from a functional add. Just like in C, you can create wrappers for your C++ code that work in C, you know.
Cool, all right. That's it.
Thank you very much.
Cheers.